Okay, so 25 says 10 to the x equals 0.01. So we need a big number 10 to be a small number. That idea I would like to start with because I think that is key in knowing what's happening here. If I need a big number, 10, to be a very small number, I need this exponent to be negative. So as far as just thinking through the problem, that's something to consider. What I need to do, what my goal is, I need the same base, and I can't really tell what the base is right here. So what I want to do is I want to rewrite it as 10 to the x equals, and what did I say yesterday? If it was 1 decimal, it was tenths. If it's 2 decimals, that's 100th. So that is something that when we were in elementary school, Javier, I don't know what you would have done. Somebody would have made us write this a whole bunch of times. So we finally got that idea of tenths, hundredths, etc. So I know that 10 and 100 have 10 in common. I can rewrite this as 10 to the x equals 1 over 10 squared. And now I have the same base almost. It's just that the 10's in the bottom, and I need it to be the same, like level. I can't compare them like this because this is a big number and this is a small number. How you get this whole thing to the top is you raise it to the negative 1 power. So if I say 10 to the x equals 10 to the negative 2, 10 to the negative 2 is equivalent to 0.01. So some people can do that because they can think through this in their heads. Others of us need to see it as 100 and then squared and then move it. And that either way is perfectly fine. But now that we have the exact same base, we can just say this is our answer. X equals 2. Negative 2. X equals negative 2. How about that? Get the same base. 30. 30 says 1 over 5 is to the x minus 4. And then 625 is to the 1/2. So what I'm trying to do is solve for the exponent. In order to do that, I need the bases to be the same. They gave me a big hint here because they told me 5. Go for 5. So I'm going to do like I did for the last one. I'm going to move the 5 to the top. And what it does, which is important, is it makes 5 to the negative 1 also to the x minus 4. That means that I have to distribute this. So when I actually solve it, I'm going to need to say negative 1 and x minus 4. The negative 1 affects both the x and the 4. That's important. How about 625? Well, if you don't know, you could probably guess that 625 has 5. Okay, so 5 goes into 6 once, then into 12 twice, then into 25 5 times. Then you might start to recognize it. Again, it goes twice, 25 times, 5 times 5. So when you get to 4 5s, you can say this is equal to 5 to the 4th. That's the 625 part. 625 is 5 to the 4th, also raised to the 1/2 power. So at this point, I have the same base, 5 and 5. This is negative 1 times x minus 4 on the left. Over here is 4 times 1/2. So we have to be really good about our exponent rules. What is 4 times 1/2? How much is that? 2. If it's too little for you to do the math right here, or if the power to a power, like written like that, is confusing for you, you need to write it to the side and do the math. And now this is an algebra 1 problem that we can solve easily if we distribute the negative x and then the plus 4. We're going to say negative x equals negative 2, so x equals 2. So negative x plus 4, subtract 4, we get negative 2. Yep. Multiply both sides by negative 1, and we get positive 2. So 30, how's that? So this had more stuff to it because we had to move this one and change this one. Do you get how I'm putting it in parentheses and then taking it power to a power? Okay. 35. $35 says 1/2 to an exponent, 1/4 to an exponent. And there are multiple ways that I can see how to work this problem. There's a really short way though, and that's the way I'd like to go. How can I change 1/4 into 1/2? Right? So that means 1/4 equals 1/2 squared. So if we replace this with 1/2 squared, actually squared there, that's better. I don't want it to look like the 1 is squared, the whole thing is squared, times x minus 5 equals 1/2 to the x minus 3. Now I have the same base. You don't have to make it the base of 2. You could, but then you'd have to make both sides negative, so you don't have to. As long as it's the same base, it doesn't matter. Does that make sense? And that's going to help us when we get to the one with e in it. So now we have the same base. We can set these two guys equal to each other. X minus 3 equals 2x plus 10. So I went ahead and distributed that. And then I'm going to subtract x because that'll give me a positive x. Going to subtract 10. So negative 7 equals x. 35. Yeah. Negative. Are we subtracting? Did I add wrong?
Oh, that's right. Yeah, yeah.
Oh, this is negative 10. All right. Okay, so ignore all of that because I had the wrong sign. Let's rewrite. This should be 2x minus 10. That makes it x minus 10. So we should write everything out and not assume stuff. So now it's plus 10? Wait. So that's positive 7? What did I have before? Well, that didn't work. I shouldn't have got negative 7. 35. 7. Okay. I don't know what I did, but this is better. Look to this one. So, I honestly don't know how to tell you how to find the right base. Because Jack could choose something, Dix could choose something else. We could have chosen the bases 2 and moved everything to the top. You could have made this to the 1/2 power, made this 1/4. Like that would have been hard. I wouldn't go there. But there are multiple ways you can solve these problems. You just have to work all the rules very carefully, like distributive that I did wrong, and try not to make mistakes along the way. So 46 was our last one. 46. The problem says, so this is the one with e. E to the x plus 2 all cubed equals e to the x times 1 over e to the 3x. So these are all exponents. All right. There's one simple thing I can do on the left. What is it? On the left, the e is on the top. What can I do? I think I had a bead for this. What does it mean to be e to the x plus 2 to the third? I have 2 exponents. How can I make it just 1? Like I have this one and this one. I could rewrite this as e to the what? So this would be 3x plus 6, right? So 3x plus 6. So now I just have one exponent. That makes it a little bit easier. Now what? Well, on the right-hand side, they wrote it kind of awkwardly, but they really mean the same thing as e to the x over e to the 3x. When you have the same thing on the top and the bottom, even if it's e, then if we have the same base, we can do stuff with the exponent. We keep the base and do what with the exponent? Let me show you a counterexample that you could definitely do. What if I said this was x over x squared or x cubed? What would you do? X to the negative second, right? Because we got more on the bottom. So either 1 over x squared, but you keep the base and you say 1 minus 3 is negative 2. That's why it's on the bottom. So we keep the e, then we say the top one, x, minus the bottom one. So this is just an exponent rule. It looks really awkward. It's really not that bad. So you have to just go back to the rule. Do I have the same base? The base is e. I have the same base. So I'm going to write it down, e. And then I'm going to say top one minus bottom one. That's x minus 3x. What is 1x minus 3x? Negative 2x. So it's simply exponent rules with a twist because we didn't have a base of x or a base of 7. The rules are exactly the same. So now do we have the same base? If we have the same base, so now that we've gotten over the part where the base is e and we don't like it and it's gross, it doesn't matter because e equals e. That means the exponent equals the exponent. 3x plus 6 equals negative 2x. Add 2x to both sides. 5x minus 6 equals 0. 5x equals positive 6. So x equals 6 fifths. 46. Negative 6 fifths. What did I do? I did something bad. Apparently.
Why is it negative?
Yep.
I think you take away the negative, like minus 3x. Then that's negative.
Well, did I write it down right? X plus 2 times 3. That's 3x plus 6 squared. So I made a mistake. Here it is. I did that in my head like I was thinking I was going to do it, and then I wrote it down wrong. So don't be a dummy. This says plus 6. It should still say plus 6. When you put it on the other side, it becomes minus 6. Then the whole thing is minus 6. My bad. Be careful from step to step. Either do it in your head or don't. I was doing both, in my head and writing it down, and I undid myself. So it should be negative 6 fifths. So it doesn't matter what the base is. It could be E. It could be Y. It could be Z. It could be 7. It could be 2. It could be 3. It doesn't matter as long as you have the same base. If you have the same base, then you can do things. You can multiply them and add the exponents. You can divide them and subtract the exponents. You can set them equal to each other and make the exponents equal, as long as you have the same base. So if you didn't finish this, go back and finish it. This will help you with your Khan Academy too. There are some problems like this on Khan Academy. I don't know, Javier, if you tried all the Khan Academy, but there are some like this. Did you have any like this? Or was it mostly graphing?
No, it was mostly graphing.
Okay, so I believe there are some where you have to get the same base. You probably want paper for that. Just because it's Khan Academy doesn't mean you don't get to write it down. So do write stuff down. Okay, so this is us going. There was stuff like, okay. I thought there was.